Hey there and welcome. Have you ever stopped to think about why your window is made of glass and not, say, wood? Or how a giant boat can float when a tiny little key sinks right to the bottom? I mean, it seems kind of obvious, right? But behind all these simple facts is a really powerful idea, the science of sorting. So today, we're going to pull back the curtain and look at the simple rules we use to make sense of, well, everything around us. All right, let's kick things off with a little puzzle for you. Take a look at these things: a set of metal keys, a comfy cotton shirt, and a simple glass of water. What's the one basic thing they all have in common? Go on, take a second. If you were thinking, well, they're all made of different stuff, you totally nailed it. And here's the wild part. Your brain is already an absolute pro at this. Every single day, you're instinctively grouping things based on what they're made of, and you probably don't even realize you're doing it. But that leads us to the really big question. Why even bother? I mean, why do we sort everything? And listen, this isn't just something for scientists in lab coats, okay? This is a practical, everyday superpower that we all have. Think about it like this. Imagine walking into a grocery store where all the food is just thrown together in random piles. It'd be total chaos, right? A smart grocer doesn't do that. They sort. All the biscuits go here, the soaps go over there, the grains in another aisle. And just like that, the chaos becomes an organized shop where you can actually find what you're looking for. And that right there is exactly why we sort materials. It brings order out of chaos. It lets us study the unique properties of different materials. And this is the really important part, it lets us see patterns in how they behave. Okay, you ready? Let's dive in. So, where do we even begin? Well, we start with the tools we were all born with, our senses. We're talking about how materials look and how they feel when you touch them. It's that simple. First up, we've got a property called luster. It's really just a fancy word for how shiny something is. And what's so great about this is that it's a super clear visual clue. You know, metals like gold and copper have a high luster. They're shiny. But then you have stuff like wood or chalk, and they're just dull. Boom. Just like that, you've got your first sorting bucket. Shiny or not shiny. Next, let's talk about hardness. And it's exactly what it sounds like. How easy is it to squish something or scratch it? You know how you can just squish a sponge in your hand? That's a soft material. Now go try to scratch a stone with your fingernail. Yeah, good luck with that. It's hard. There's even a whole scale for this, from super soft talc all the way up to diamond. This one simple difference is absolutely crucial when you're deciding what to build stuff with. All right, so we've covered how things look and feel. Now let's, get our hands a little wet. Because for our next set of properties, we're bringing in the ultimate test subject, plain old water. So first up is solubility. Basically, does it dissolve? You do this all the time without thinking. You stir sugar or salt into your drink, and poof, it disappears. It's soluble. But if you try stirring sand or sawdust into water, they just hang around. They're insoluble. And this isn't just for solids. Vinegar mixes right into water, but oil? Nope. It's always going to form its own layer right on top. So what about all those things that don't dissolve? Well, that brings us to our next simple test. Do they float or do they sink? This is buoyancy, and it all comes down to something called density. Think about a pond in the fall. Dried leaves just float right on the surface because they're less dense than the water. But that metal key from earlier, it's much denser, so it sinks like a rock. It's another incredibly simple but really powerful way to group things together. For our last category, let's shine a light on things literally. Yep, we're going to sort things based on one simple question. Can you see through it? And it turns out there are pretty much three ways materials handle light. First, you've got your transparent materials, things like glass or clean air that you can see through perfectly clearly. At the total opposite end of the spectrum, you've got opaque materials, like a block of wood or a sheet of metal. They block all the light. And then, sitting right in the middle, are the translucent ones, like oiled paper, where some light gets through, but everything on the other side is all blurred. Okay, so we've talked shine, hardness, how stuff acts in water, and whether you can see through it. Now let's pull it all together. Why does any of this matter? Because this, my friends, is where sorting stops being about just organizing and starts being about creating. So what's the big takeaway here? It's that we now have these 5 simple but super powerful tests we can run on pretty much anything. We can check its luster, its hardness, its solubility, its buoyancy, and its transparency. Together, this is our basic toolkit for making sense of the entire physical world. Here's a great way to think about it. Sorting materials is a lot like organizing your music library.
You group songs by genre or by artist, or maybe by vibe to make the perfect playlist, right? Well, scientists and engineers do the exact same thing to find the perfect material for a specific job.
And that is the whole point. That's the ultimate goal. By understanding these simple properties, we can make really smart choices. It's the reason we make windows from transparent glass, not opaque wood. And it's why boats are built from buoyant materials that float. It's all about matching the material to the mission. So there you have it. You now have the basic code, the language that governs how things are made and why they're chosen. You understand the language of materials. So the only question left is, now that you know the code, what are you going to build with it?